Let's say you're given these two velocity equations, and you're given the question, what is the average acceleration between t1 equals 0 and t2 equals 2 seconds? Do you know the answer? If you don't, keep watching this video. It wants us to find the average acceleration in 3D. How do we find average acceleration in 3 dimensions? Now, let's remember in 1D, the average acceleration is equal to the change in velocity over change in time. We could transform this into 3D by using the 3D vectors. So we could transform these two vectors for the velocity and acceleration like so, and we can plug them in to get the new 3D average acceleration equation, where the v vector represents the 3D velocity vector. We can now apply it to our example question. So this is the example here, and so we can start with writing down our 3D average acceleration equation. We can write it in this more useful form, and then all we have to do is plug in v2, v1, t2, and t1. But now we're just realizing that we don't have t and v1 vector yet, so we have to find these values by applying t1 and t2 to our equation. So our v1 vector can be found at time equals 0 seconds. For our vx component, we can apply the vx equation, and we get 0. For our vy component, we can apply the vy equation and plugging in 0 for our time, and we get 1 meters per second. Generally, a 3D equation for velocity is written like this. If we plug in the values we just found here, we can get our v1 vector equal to 1 meters per second in the y. This is our 3D velocity vector at time 1 equals 0 seconds. And we can use these same steps to apply time 2 equals 2 seconds and get the v2 vector, which the final answer for that would be this below. But now that we had the v2 and v1 vector, all we have to do is come back to our equation and apply them. So this is our average velocity equation in 3D, and then we can plug in our values that we found as well as t2 and t1. If we plug all these values into the equation, we get this here. We can distribute the negative sign, and then we get this expression below. Add up like terms, and so the y's add with the y's, and we get this. We can divide each term by 2, split up the terms into 2 here, the x and the y. Divide the amplitudes and the units for the first one, and we get negative 0.5 in meters per second squared. We do the same for the second one, getting 0.15. And then if we plug both those values in, we get this final result here. And I just want to know, this is the average acceleration of the motion of the object in 3D between the times of t equals 0 and t equals 2.